Hi everyone, good day. To this point, we've done quite a few derivatives, but they have all been derivatives of the functions of the form y equals f of x. So for those functions that are not in the form y equals f of x, will be discussed. To take their derivative, we will take it up here in implicit differentiation. I am Abigail J. Dangate of the Mathematics Department of Caraga State University. And let us now start implicit differentiation. Example number 1. Find y prime for x times y equals 1. For our first solution, we can always look at our function and solve for y in terms of x. So we can solve for y in terms of x by dividing both sides by x, so that we will have y equals 1 over x. Okay, and by this time, we can already take the derivative, and the derivative is negative 1 over x squared. For our next solution is, we take the derivative of x times y. That y is in terms of x, of variable x. That is the derivative of these two with respect to x, equal to the derivative of 1 with respect to x. Derivative of y of x with respect to x is simply the derivative of y with respect to x, or the y prime. Means that if we take the derivative of these two products here, the product of x and y of x, we then apply product rule. And it means we have, for product rule, we say, we copy y of x, okay? And then we take the derivative of x with respect to x, that is 1, plus x, and we take the derivative of y of x with respect to x. That is equal to the derivative of 1, or our constant 1, with respect to x is 0. That means we have already 1 times y of x is y, or plus x times y prime, because we have x here, and this part here is just the y prime, equals 0. Solving for y prime, we have transpose y to the other side. That will become negative y. And then divide both sides by x. We have y prime now equals y over x. That is equal to, the y here is 1 over x. Substitute that y into y over x, 1 over x. And then over x, we have negative 1 over x times 1 over x, and that will give us negative 1 over x squared. For our next example, differentiate each of the following. Okay, for letter A, we'll have 5x cubed minus 7x plus 1 to the power of 5. That's our first function. So what shall we do with that? We take the derivative of that with respect to x. So we will take the derivative of to the power of 5. So we have 5, okay? the usual taking of derivative. So we take 5 down, copy everything in the parentheses so that we still have the power deducted by 1. So it becomes 4. Okay, that will be our next factor. So we have 5 down, copy everything, then minus 1 to its power. Next, take the derivative of what? Take the derivative of 5x cubed minus 7x plus 1. And it will give us 15x squared minus 7. Are we done? Yes. That is the derivative of 5x cubed minus 7x plus 1 to the power of 5 with respect to x. Let's have the derivative of f of x to the power of 5 dx. So what do we have? We say 5, and then we copy f of x to the power of 4. Okay, and then last one is the derivative of what's inside. That's it. Next, the derivative of y to the y of x to the power of 5 dx. It is equal to 5 times y of x to the power of 4 y prime of x. That's it. That's for differentiation of a function with respect to x. But then, let's have this one. Sine of 3 minus 6x. With respect to x, we say, what is the derivative of sine 3 minus 6x? The outer function is sine, so we say sine of 3 minus 6x is cosine of 3 minus 6x. And then after that, we take the derivative of what's inside the parentheses, which is negative 6. So we have negative 6 here. In all, we have negative 6 cosine of 3 minus 6x. Next, the derivative of sine of y of x with respect to x. It is equal to what? It is equal to the outer function is sine. So sine of what's so the derivative of sine of y of x is cosine y of x. And the derivative of y of x is y prime of x. Letter C. The derivative of e to the x squared minus 9x and e to the y of x. So we have the derivative of e to the x squared minus 9x is, you copy e to the x squared minus 9x times the derivative of that x squared minus 9x, we have 2x minus 9. Next, of e to the y of x with respect to x is equal to e to the y of x times the derivative of y of x, you simply say derivative of y of x, or y prime of x. Find y prime for the following function. What if we have x squared plus y squared equals 9? So what will we do? We take the derivative of, okay, so first we take the derivative of x squared, y squared, 9, all with respect to x. So let me write first before we go on with our solution. Let me write here the derivative of x squared with respect to x. Actually, because this is x, so we simply say the usual 2x. It's the usual taking of derivative we have. But in case the variable is different, like we are talking about x and we have here y, then there's always a difference in our answer now. So say 2, the derivative of y squared is 2y also. But you should add the derivative of y with respect to x. Or that is the same as y prime, or first derivative of y with respect to x. So that's the difference. Now, if we take the derivative of 9, because 9 is a constant, we then have 0. So let me show you the solution we have in our PowerPoint. Means that you write the derivative of x squared with respect to x, and the derivative of y of x to the power of 2 is 2 times y of x, and then y prime of x. That's what I write here. And that is equal to 0. Or you can simply do like that, like what we have here. Okay? And thus, we have y of x, or y prime of x, is equal to, you transpose 2x to the other side. Okay, let me write again. So in that part, that 2x plus 2y prime equals 0. We just transpose those with a y prime, just have that in the left side. And to the right side, we have negative 2x. Divide by 2y to both sides, so that we are left here with y prime. And we can cancel negative, the 2 and the 2. So we have negative x over y. That's why we have an negative x over y here for y prime. Okay?